We've had strong solar activity, 19 solar CME flares in 24 hours, a total of 5 M-class explosions, and a powerful X2.2 class flare. This is according to Space Weather announcement. Solar activity is intensifying. In the last 24 hours alone, the sun has produced more than 19 solar flares. The total includes 5 M-class explosions and a powerful X2.2 class. The fuselage is likely to continue as colossal sunspot complex AR2-99394 turn towards the Earth in days ahead. And you'll see that they're all grouped together. Here they are. They're all grouped together in the same quadrant. There's another one down here, but that's a smaller one. And this is the area that we're talking about. So we have the flares AR2992, which rotated yesterday over the southwestern limb of the sun. The sun just produced another X flare. Earth orbiting satellite detected the X2.2 class explosion April 20th at 3:57 UT. Remarkably, it came from a far side sunspot. The source of the flare is AR2992, which yesterday rotated over the southwestern limb of the sun. The sunspot is no longer visible at all. It is hidden behind the edge of the solar disk because the blast site was eclipsed. The actual flare was almost certainly stronger than its nominal rating of X2.2. Shortly after the flare, the U.S. Air Force reported a Type 2 solar radio burst. What is a Type 2? Now, according to Space Weather, the Type 2 solar radio burst, according to Australian Telescope National Facility, coronal Type 2 solar radio bursts often appear as two bands with a frequency ratio of 1.8 to 2 in the range of 20 to 400 megahertz that drift slowly towards in frequency at a rate consistent with an MHD shock moving through the solar corona and driving radiation near FP and 2FP. Similar slow drift emissions have been observed in the solar wind at frequencies from 20 kilohertz to 20 megahertz and directly associated with shock waves measuring in situ by spacecraft. It has long been hypothesized that the Type 2 radiation is produced by nonlinear processes involving Lang-Muir waves, which are driven by electronic beams accelerating the shock. And indeed, Cairns in 1986 pointed out that in the rest frame of the propagation shock, the situation is quantitatively identical to Earth's bow shock, and that the reflection acceleration of electrons into the foreshock region upstream of the Type 2 shock should result naturally in electronic beams by the same physics described above for Earth's foreshock. This suggests that a foreshock model for Type 2 bursts is a natural way to develop the theory, but as described next, multiple unresolved observations questions have hindered the development of the theory of Type 2 bursts, and it's only in the last 3 years that data from the WIND spacecraft have started to clarify the situation significantly. So, going back to the Space Weather article, the M-class. What are M-class? Well, the classification of X-ray solar flares. The flare is an explosion of the sun that happens when energy stored in twisted magnetic fields, usually above sunspots, is suddenly released. Flares produce a burst of radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. Scientists classify solar flares according to their X-ray brightness in the wavelength of 1 to 8 angstroms. There are 3 categories. X-class flares are the big ones. They are major events that can trigger planet-wide radio blackouts and long-lasting radiation storms. And as we said before, there was one X2.2 class flare, even though astronomers believed that it was stronger. and we had 19 M-class flares. They're medium-sized. They can cause brief radio blackouts that affect Earth's polar regions. Minor radiation storms sometimes follow M-class flares. Compared to X and M-class events, C-class flares are small, with few noticeable consequences here on Earth. So, the very strange activity, the 19 flares in 24 hours. The X-class solar flare, the sun produced X-flare. Earth orbiting satellites detected the X2.2 class explosion April 20th, as we said. Radiation from the flare caused a shortwave radio blackout over Southeast Asia and Australia. And let's look at the blackout map. And this is the blackout map, as you can see. Basically, it's southeastern Russia, Kamchatka Peninsula, Japan, China, India, of course, Korea, the Korean Peninsula, Indonesia, Australia. That's the blackout map. High frequency affected by 1 dB absorption. And of course, the more intense is the red. Yellow and green are less. Okay, so this is all the blackout map, as we said. That's it. Mariners and ham radio operators in the area may have noticed loss of radio contact at frequencies below 30 megahertz for as much as an hour. Shortly after the flare, the U.S. Air Force reported a Type 2 solar radio burst, a natural form of radio noise produced by shock waves in the sun's atmosphere. Ironically, this radio burst filled the loudspeakers of shortwave radios on the day side of Earth with static during the radio blackout mentioned above, and terrestrial radio stations were briefly replaced with solar noise. SOHO coronagraphs have since detected a CME emerging from the blast site. And the CME will not hit Earth, thank goodness. It is well outside the strike zone. No surprise considering the far side location of the sunspot. So we have to stay tuned for updates, solar flares alert. Okay, and this is the solar flare, 20th of April 2022. And here we are. This is it right here, as you can see. Around 4 UTC, lasting about 4 or 5 hours. And thank goodness it will not hit Earth. It's well outside the strike zone, and we're lucky about that. But how lucky will we be in the future? It seems to be that we're getting a lot more solar flare activity. Just about every week we're having, but this is very unusual. I'm not an astronomer, but 19 solar flares, 19 in 24 hours. Okay, I'll leave a link below for you for space weather. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.